So section 2-3 discusses solving inequalities by multiplying and dividing. So this first part right here is really explaining why we're going to do what we're going to do here in a minute. If we take an inequality, 7 is less than 12, and that's a true inequality. And let's say that we multiply both sides of the inequality by a positive number, in this case 3. 7 times 3 is 21. 12 times 3 is 36. Do we get a true inequality again? Is 21 less than 36? Yes. All right, what if we divide? Let's take a true inequality, 15 is less than 35. What if we divide both sides by a positive number? So here you see us dividing both sides by a positive 5. 15 divided by 5, this is actually an error here. It should read 3. And then, excuse me, I still have a cold. 35 divided by 5 is 7. Is 3 less than 7 still a true statement? Yes. Well, why did I even go over that? Well, look what happens if we multiply or divide both sides by a negative number. So here's a true inequality. 8 is greater than 4. What if I multiply both sides by negative 2? Again, there's an error on here. There should be an 8 here. 8 right in there. Maybe I'll make that blue so you can see it away from the inequality sign. So here's an 8 that should be in there because we're taking the 8 down here and multiplying both sides by negative 2. Negative 2 times 8 is negative 16. 4 times negative 2 is negative 8. Notice that all of a sudden the inequality sign went from a greater than to a less than. Why? Well, if you look at negative 16 and compare it to negative 8, all of a sudden you have to flip. If you kept the inequality sign where it was, so let's just pretend that we had kept the inequality sign as a greater than. If you look at negative 16 and negative 8 on the number line, here's 0, here would be negative 8, and here would be negative 16. Because negative 16 is to the left of negative 8, negative 16 is smaller than negative 8. So saying that negative 16 is greater than negative 8 is incorrect. So as a result, we have to flip that inequality sign. So it's not going to let me erase this inequality sign that I put in there. But as a result, we have to flip this greater than and make it less than for it to be a true statement. So look at the division. Here's a true inequality. 12 is greater than 4. You would agree that that's true. But what if we divided both sides by a negative 4? 12 divided by negative 4 gives us a negative 3. 4 divided by negative 4 gives us a negative 1. Again, negative 3 is to the left of negative 1. It's less than negative 1. We have to change that inequality sign of greater than to a less than. So the moral of the story is, and it's all written down here. Whoops, now I'm going to take this away. There we go. So the moral of the story is, whoops, that still didn't take away. Hold that thought. There we go. Well, we're going to ignore that for the time being. So the moral of the story is, move that out of the way, that if you multiply or divide an inequality by a positive number, the inequality stays the same. So multiplying or dividing both sides by a positive number does not affect the truth of that inequality statement. However, if you multiply or divide an inequality by a negative number, you have to flip that inequality sign. Otherwise, you don't have a true statement, so you have to flip it. So let's look at some problems. So example 1. If we're to solve the inequality sign, or if we're to solve the inequality, we are going to divide both sides by 3. Notice I am not dividing by a negative. Since I'm not dividing by a negative, I don't flip the inequality sign. So the 3's on the left cancel, and you get x is greater than negative 9. So if we're to graph it, negative 9, our boundary point, goes in the middle. So I've got an open circle at negative 9 because there's no equals to. And it says it's greater than, so we're going to put an arrow to the right. My favorite checkpoint is 0. 0 is somewhere over here, which means it's in the true statement because that's where the arrow is going in the direction of. So if I take 3 times 0, which is 0 greater than a negative value, 27? Yeah, 0 is always greater than a negative, so that's true. So the fact that the line is over here in the direction of 0 makes me feel and believe that my graph of the inequality must be correct. Look at example 2. Don't let a fraction bother you. To deal with fractional coefficients, remember we multiply by the reciprocal to both sides. So I am not multiplying by a negative. I do not flip the inequality sign. The 3's here cancel and the 2's cancel, so I get r is less than. The 2 cancels into the 6 3 times, and so we get 3 times 3 is positive 9. So 9 is my boundary point. It goes in the middle. So we have an open circle again at 9 because there's no equals to, and less than means an arrow going to the left. On this example, to solve for the inequality, I have to divide both sides by -8. Because I'm dividing by a negative, warning bells should be going off in your head, I have to flip the inequality sign to its opposite sign. So it was a greater than sign, now we're going to flip it to a less than sign. The left side becomes x is less than, the right side becomes -9. So if I were to graph that, and then we're going to check it, here's -9 as my boundary point. So I would have an open circle at -9, x is less than, so an arrow going to the left. So let's check our answer. My favorite checkpoint is 0. 0 is somewhere over here where it would be a false statement because there's no line over here where 0 is. So -8 times 0 is 0. Is 0 greater than 72? False. 0 is not greater than a positive number. So this does look like a correct solution. If you had not flipped the inequality sign, your inequality would have said x is greater than -9. You would have had the arrow over here, which clearly 0 should not be a solution. As we plugged it in here, it shows a false statement. So checking it should help you determine whether or not you forgot something like changing a sign or flipping the inequality sign, that type of thing. So look at example 4. To solve, focus on the variable. X is being divided by -5. So to undo that, we're going to multiply both sides by -5. Again, because we are multiplying by a negative, that less than or equal to sign becomes a greater than or equal to. Whoops. Let's make it prettier. So it becomes a greater than or equal to sign. So -5 times -3 is a positive 15. And then these cancel, and we get an x. Now, we don't like having an x on the right, so we need to play Vanna White, flip the x and the 15. When we flip the x and the 15, we have to also flip the inequality sign back again to a less than or equal to sign. So our solution is x is less than or equal to 15. So we're going to check it. So put 15 in the middle. So at our boundary point of 15, we have a closed circle because of the equals to, and the less than sign means we're going to go to the left. My favorite checkpoint is 0. 0 is somewhere over here, which is in the direction of the line, which means 0 should be a solution. So if we put 0 up here, 0 divided by -5 is 0. -3 less than or equal to 0. Are negatives less than or equal to 0? Yes. That's a true statement, so the line should be going in that direction. Last problem is a word problem. So Ryan has a $16 gift card for a health store where a smoothie costs $2.50 with tax. What are the possible numbers of smoothies that Ryan can buy? So let's look. We're going to let x equal our unknown. That would be the number of smoothies So Ryan has a $16 gift card, so that implies he cannot go over $16. So to set up our equation to solve, he wants to buy smoothies, and you don't want to set up an equation where x is by itself. So every time we buy a smoothie, so x is the number of smoothies, we would multiply that by $2.50. That would give us the total costs of however many smoothies we bought. That has to be less than or equal to $16. So then to solve for x, to undo multiplying by 2.5, $2.50, we are going to divide both sides by 2.50, and so then we get x is less than or equal to, let's see, 16 divided by 2.5, 6.4. So you can't buy 6.4 of a smoothie. They're just not going to sell it to you. You can't buy 6.2 of a smoothie. What you can buy is 6 smoothies, 5 smoothies, 4 smoothies, and so forth. You can't buy 7 smoothies because you don't have enough money to buy 7 smoothies. So essentially, the solutions that x can be will be 1, 2, 3, 4, 5, and 6 because smoothies come in whole numbers. Those are the only whole numbers that are less than 6.4. So therefore, Ryan can buy 1, 2, 3, 4, 5, or 6 smoothies.